Hello and welcome to the next video of matrices. In today's video, first we will learn what do you mean by transpose of a matrix and what is its properties. Now, transpose of a matrix is when you interchange the rows and columns. Look here, we have row 1, row 2, row 3 and column 1, column 2. Now, if I write row 1 and write it in the form of column 1 and I convert row 2 into column 2 and then I convert row 3 into column 3. So this is what is meant by transpose. So A is a matrix of order 3 by 2 and the transpose of A, which is represented by A dash. In some books it is also represented by A to the power T. Okay, so this is what is transpose, interchanging of rows and columns. So obviously now the order will also change. Here initially the order of A was 3 by 2. Now the order of A transpose is 2 by 3. Right, so this is what is meant by transpose. Now let's talk about properties of transpose. If I'll take the transpose of the matrix again, so obviously the transpose of the matrix, if it is taken once again, will give you the original matrix. You can just take an example and prove it, right? You can check it. If you take, if you multiply any scalar multiple into A, right, and then take a transpose, or you just multiply the scalar constant by A transpose, it is one and the same thing. Right, here also every element of A transpose will get multiplied by K. Here first you are multiplying it by K and then you are taking transpose. So it is one and the same thing. When there is a plus sign in the transpose, A plus B whole transpose will give you A transpose plus B transpose. Now this is an important thing to note, that AB whole transpose is B transpose A transpose. This is what you should remember, that when you take, there are two matrices whose multiplication is there and you are taking AB whole transpose. Since you remember that order always gets changed, right? So A into B करके suppose C आया जिसका order 2 by 3 आएगा, तो obviously उसका order जो है वो change हो जाएगा. That is why it is B transpose into A transpose. So I want you to make a note of this, right, children? So this is all the property, this is what is meant by transpose of matrix and its properties. Let's learn two important matrices which is named after this property. First is known as a symmetric matrix. When do you call a matrix as symmetric matrix? A matrix is said to be symmetric matrix if A transpose is equal to A. Okay, so if somehow we get A transpose is equal to A, then it is known as symmetric matrix. Let me explain you with the help of example. For this, you should always remember that this and this element will always be equal. This and this element will always be equal. And here, this element and this element will always be equal. Diagonal can be anything. Now, let's try and take A transpose. If I take A transpose, first row can be written as first column. So root 3, 2, 3. Second row, second column, 2, minus 1.5 and minus 1. And then third row, third column. So 3, minus 1, 1. So check. Is this, in this case, if I see A and A transpose are same. And again, very, very important thing. Why are they same? Because this element and this element was same. Right, here and here I've written same elements, matching elements, and this element is equal to this element. So this is how you will write transpose of any matrix, okay, which is a skew, which is a symmetric matrix. Symmetric matrix means A transpose will be equal to A. So this is what I want you to make a note of, right? Now let's talk about the next definition, that is a skew symmetric matrix. What do you mean by skew symmetric matrix? If A transpose is equal to minus of A, then we say here A transpose was equal to A. In skew symmetric, A transpose is minus of A. There is only a sign difference between the. Then we say that the matrix is skew symmetric. Then we have a very, very important thing to note, children. The diagonal elements of a skew symmetric matrix are always 0. Let me explain you how. If I say A transpose is equal to minus of A, that is Aij will be equal to minus of Abi. This is what is meant by general. And for diagonal matrices, children, you know, diagonal matrix elements कौन से होते हैं? For diagonal elements, you know that I and j are same. When I and j are same, then aii is equal to minus of aii बन जाएगा, यानी कि twice of aii will be equal to 0. So this implies aii will be equal to 2 will go that side, 0 divided by 2, which is 0. So this is a very important thing about a skew symmetric matrix कि उसके जो diagonal elements है वो हमेशा 0 होते हैं. And this can also come as a one marker question, that why the diagonal elements of a skew symmetric matrix are 0. So I have already told you why. Again, now what is the main thing which you have to remember? तो ये तो clear हो ही गया कि diagonal elements 0 होते हैं. अब check करो, ये और ये position sign से differ करती है. यहाँ पे ये दोनों positions exactly same थे. Again, ये position and ये position भी sign से differ करती है. And again third, ये position and ये position भी sign से differ करती है. So this is how you will write any skew symmetric matrix. Right? Here the difference, here the element was exactly same in these positions, and here in these three positions the elements differ by sign. अगर यहाँ +2 रखा है, सपोज करो मुझे इस एग्जाम्पल देना है, तो मैं कैसे लिखूंगी? सबसे पहले तो मैं डायगनल एलिमेंट्स को 0 0 कर दूंगी. फिर यहाँ 2 लिखा है तो यहाँ -2 लिखूंगी. यहाँ 1 लिखा है तो यहाँ -1 लिखूंगी. एंड सपोज यहाँ -3 लिखा है तो यहाँ +3 लिखूंगी. दैट इज व्हाट इज मेंट बाय स्क्यू सिमेट्रिक. अब आप इसका ट्रांसपोज, इफ दिस इज C, if I take this as C children and I want to take C transpose, check करो क्या आएगा? 0 to 1, ये रो फर्स्ट रो फर्स्ट कॉलम, this is -2 0 -3 and this is -1 3 and 0. And check, if I take minus sign common children, what will I get? 2 0 2 1 -2 0 -3 and this is -1 3 0. I'll get minus of C. So that is why it is skew symmetric. Okay. Now let's learn a theorem. Theorem 1 and Theorem 2 about symmetric and skew symmetric matrices. Two matrices are said to be, you can express a matrix A with real number entries as A plus A transpose is symmetric and A minus A transpose is symmetric. तो अगर आपको कभी A matrix given है तो हमें पता होना चाहिए कि जब हम A plus A transpose की बात करते हैं वो हमेशा symmetric होता है, और जब हम A minus A transpose की बात करते हैं that is always skew symmetric. Now let's prove it. How will we prove? We will use the properties of this transpose. Let me consider the first case. This is case 1 children. I am taking this. This is equal to B. So B is equal to A plus A transpose. Let's take transpose on both sides. So transpose, taking transpose, you know the property, right children? A plus B whole transpose is A transpose plus B transpose. Just open the bracket. So this will be A transpose plus A transpose का transpose. Again you know this. अगर एक एलिमेंट का ट्रांसपोज करोगे तो वो मैट्रिक्स वापस आ जाएगा, तो वी गेट A, राइट? आफ्टर दैट we get A plus A transpose. Now you know that A plus B addition is commutative in nature. A plus B is equal to B plus A. So can I write A plus A transpose, A transpose plus A as A plus A transpose, which is equal to B. So B transpose is equal to B, hence it is a symmetric matrix. क्योंकि definition of symmetric matrix यही कहती है कि अगर एक का complement दूसरे के equal है तो वो symmetric होते हैं. Now let's take case 2. Let's take this as C. So C is equal to A minus of A transpose. Again let's take transpose both sides. So this will be A transpose minus of A transpose का transpose. Again you know, यहाँ तो bracket normally open हो गए और यहाँ bracket क्यों open है? Again same reason कि इसको A plus of minus of A transpose का whole transpose लिख सकते थे. Again हमें ये पता है A plus B transpose is A transpose plus B transpose, right? So same reason. So that is why it is A plus minus of A, क्योंकि A transpose का transpose is again A. Again this reason is again the same, right? So this is A minus of A transpose minus of A, right children? So this was transpose, right? So A transpose minus A. Now can I take minus sign common and अंदर क्या रह जाएगा? A minus A transpose. which is equal to C. So C is equal to A minus C dash, यानी कि C transpose is minus of C. That means, can I say C is a skew symmetric matrix? So this is what is proved. यही prove करना था कि for any matrix A plus A transpose is symmetric and A minus A transpose is skew symmetric. अब theorem number जो 2 है वो इसी का continuation है. You can express any matrix as sum of symmetric and skew symmetric. So it is continuation of this. Check here, children. We have already proved that A plus A transpose symmetric है. So can I say अगर A plus A transpose symmetric है, so therefore half of A plus A transpose भी symmetric होगा, right? Scalar से multiply करने में से कोई फर्क नहीं पड़ता उसकी property में. So this is also symmetric. Also we have proved that A minus A transpose is skew symmetric. So again half of A minus A transpose B is also skew symmetric. Now you just add these two. Check. After adding these two, don't you think I will get A? Check karo. Half of A plus half of A transpose plus half of A minus half of A transpose. So this and this gets cancelled. Half A is A. So check. We are getting a square matrix A which can be expressed as this is symmetric matrix and this is skew symmetric matrix. So hence we say that any matrix can be expressed as a sum of symmetric and skew symmetric matrix. That is all the concept which you need to solve the next exercise. Okay, children. So if you have any doubt in the concept, please let me know. We will do the exercise in the next video. Thank you, children.